Hello and welcome to our session. Today we want to talk about a paradigm shift in technical communication, where we put metadata first in the content lifecycle. But let's introduce ourselves. My name is Ulrike Parson. I'm the founder of Parson AG, a service provider for technical communication located in Hamburg, Germany. And we are consultants for content management and content delivery. And we are also technical writers creating smart content.
And also hello from my side. My name is Achim Steinacker. And in Empolis, I'm a director for delivery and operations, mainly responsible for all our knowledge graph projects. I have quite a few years experience in planning and implementation of content delivery projects, and also with establishing and managing metadata management for the technical communication.
So we are talking about a paradigm shift in technical communication. Let's have a look at our current processes in technical writing. Most technical writers work in a component content management system. And in the system, you work very efficiently. You have modules that have metadata assigned for controlling variant management. You have workflows to control and monitor editing, reviewing, and publication, and also translation. And you have a user management so that only specific users can access the systems. The metadata that you have in your component content management system is usually linked to variant management, because we want to use the same content for the documentation of different product variants or different modules, or for manuals for different target groups. We also have administrative metadata like the content status or the translation status or the date of publication. So the classical workflow in technical writing today is a three-stage workflow consisting of creating, translating, and publishing. In the creation phase, we research, we write the content, and we talk with the engineers and manage our terminology. In the translation phase, all the translations are made and reviewed, and maybe also there's a layout created. And in the publication phase, we define the layout and generate the output formats. For instance, a PDF or an HTML. Most CCMSs have interfaces in order to reuse content from other sources, but also to send content to other sources. I brought some examples. Could be a product information management system or a product lifecycle management system from where you get product information like parts or technical parameters, stuff like that. Translations are usually managed with a translation management system, and also there are interfaces between content management systems and electronic part catalogs for spare parts. So this is our CCMS. The CCMS delivers content in the form of documents, and then they are processed in the further product life cycle. So we leave the authoring stage and go to the delivery stage. The information products that we generate are then integrated into the product in order to be shipped. And the integration into a product can be done by means of a context-sensitive help. It can be a printed manual or a PDF that is packaged together with the product. It could even be a HTML version of the documentation that is integrated in the HMI, or the documentation will be available on download areas on websites or in a content delivery portal. After the stage of delivery, when the product is sold and in used, also our information that we write in the technical documentation is used. And users have a lot of places to go to where they find information. They have product websites, they have support website, help centers, training, e-learning website. Maybe there are data sheets they can download, or maybe they have a content delivery portal. So usually the documents are distributed to several sites where users can use this information. So this is the classical workflow and the classical content life cycle. But with the rise of digitalization, there are a lot of new use cases that we need to, for which we need to send content from the technical documentation, because our content is able to support these use cases. And I've brought a few examples to illustrate why we think that we need a paradigm shift that puts metadata first. And I will start with chatbots. Chatbots are increasingly used by companies because they are kind of a first line of support and may relieve the hotline of the manufacturers from too much work. They can answer frequently asked questions. In order to do so, they must be able to actually detect the intention of the question. They must know which product the users are talking about and which problem or error they are talking about. So they need to understand the intent, and then they need to be able to find content in order to answer the user's questions. And also maybe hit the right tone of voice, because there may be different users who actually use that content, from service technicians to older people to students. And in order to recognize what the users want, and in order to find the right information that the chatbots can actually give to the users, they need metadata. They need information and knowledge about product variants, about functions or components the users are asking for. They need target group metadata in order to get text or videos with the right tone of voice. They need to be able to retrieve content that is specifically written for a chatbot. And of course, they need to find the right type of content, for example, troubleshooting information. The second usage scenario is the digital twin. A digital twin is a digital representation of a product, including all its interfaces, components, and services. And of course, the technical documentation needs to be shipped with the digital twin or into the digital twin. The digital twin doesn't stop when the product is delivered and put into use. It lives with the product, and its information is added to the twin by means of service reports. Maybe parts are exchanged, so the information about the new parts goes into the digital twin. Maybe interfaces are connected to another system in a plant, for instance. So all this information is collected in the digital twin, and this information includes documentation and other information types. So if somebody wants to use the information that is contained and collected in the digital twins, they, and this may be human or machine, they need to be able to access the right information. And again, they need metadata to do so. They need to find information that is tied to a specific component, that describes a specific function, and they need to retrieve specific types of information like troubleshooting or maintenance instructions. Also, they need to know for which life cycle phase the information is valid. Is it about repair, or is it about transport or assembly? And if there are events like errors, they also need to retrieve information based on event classes. And third main application scenario are self-service portals. This is another way of actually relieving or getting work away from support or from hotlines, because companies want to enable users to answer their questions themselves that they have about how to use a product, how to solve a specific working task, or how to find the reason for an error. So self-service portals are web-based portals that offer information from training, from marketing, from product information, from technical documentation, and they can help to solve problems, but they can also help to actually find a suitable product and make the right purchasing decision. So to find your way in a portal, again, you need metadata. You need metadata to build up search facets and to boost a semantic search. And as you can see here, again, we have the same type of metadata: product variants, components, functions. I'm searching for specific events, and I'm trying to solve problems by finding the right solutions. Another example is the integration of documentation and instructions with live data. This is especially important for digital twins or smart factories, where you have measurement data like pressure, temperature, and if this measurement data leaves a specific tolerance area, you may need to interfere, you may need to exchange a part, or you also this kind of information is important for predictive maintenance. So you need to find instructions based on events that happen in a machine or in a smart factory. And to find that information, to integrate your documentation with live data, again, you need metadata, because you need to know which component the specific event is connected to, which type of information you want to deliver to the service technician, and which type of event has popped up. And last but not least, we see a lot of product configurators out there. They help people to configure a product based on specific modules, interfaces, materials, properties, and functions, so that they have the ideal product for their use case. And you can support product configurators by information from the technical documentation. For example, by explanations for how a specific measurement principle works, how the temperature range of a product is defined, or why this product is suitable for medical appliances. So you can use information from the technical documentation to support the purchasing decisions of your customers. So that for this use case, so that information or options in the product configurators can find the right pieces of content, again, we need metadata. And again, it's product metadata like product variants or product functions. But the product configurators also have information about versions and revisions, sales categories, and stuff like that. That needs to be linked in the metadata. So we have, then these are only 5 use cases. We could name more in the age of digitalization. But what we wanted to show is that all these use cases need metadata to find content, to link content, to retrieve content. We always have those little red circles at the bottom saying that we need metadata for these use cases.
Okay, thank you, Ulrike, for providing all these examples where you can see that the usage and availability of metadata is a game changer in the way technical communication will work in the future. When we are looking about the first consequences of the authors, the first question is, do authors know all the usage scenarios of the content and the corresponding metadata? As Ulrike explained, the content used to fulfill all the requirements of these scenarios is not only produced by the technical communication and with authoring system, but also other content is used. A lot of metadata has to be used, which is not part of the technical communication. And how do authors know about all these scenarios, and how do they know which metadata they have to use to annotate their content and the topics they wrote? So which product properties influence the required content? Which content is actually needed for a service technician standing in front of the machine and trying to perform repair tasks? What's really specific for this component, not just the model or the family, but this component standing there and producing and doing things for quite a while now in this machine? Which parameters describe the scenario? It's most of the time not enough just to provide an error code and then everyone knows which kind of documentation is necessary. What is the concrete scenario for a request for information, and what has to be known about the content and therefore about the metadata annotated to the content to really decide if this topic, if this piece of information is useful? And as Ulrike also said, it's quite a lot of metadata. Who defines the metadata? Most of it, or a big parts of the metadata, is already there. It's already available in product information management systems, the bill of materials, the variants, the objects, the options, probably also the function. Who is defining this global set of metadata where the part which is really just necessary for technical communication is just a part? And even more, who is responsible for updating the metadata? Who is responsible to deliver metadata about new product variants to the technical communication? Who is synchronizing the metadata? What do authors need to do when products or use cases change? What has to be done when a new product variant, new functions are introduced? Who will be responsible for defining the new necessary metadata? And a really important issue of the dealing with metadata will arise when you think about the chatbots and the amount of small chunks of information that are needed to fulfill all these functions of chatbots. It's not only topics anymore that have to be annotated, but probably just a sentence or a question. No one will be able to do all these annotations manually, or otherwise, if someone has to do it, they are not able anymore to provide actual content. They will spend their time with just annotating metadata to small chunks of information. And last but not least, when thinking about defining a metadata and a metadata model, and when trying to think about information structures, are there any standards already available? Do I really have to start from scratch with my metadata model? Do I really have to define all my product lifecycle phases on my own? Or can I use an existing standards in the area of technical communication where someone else has already done the work and I can use what's there and probably just adapt it to my special needs? So thinking about the complexity of managing metadata, thinking about the amount of metadata that is needed, which is already available in other systems, and about different sources of information, it's quite clear that the metadata cannot be held in just one application, and especially not in authoring system or component content management system, because the content management systems, the authoring systems, they are just one source of information, and they are also only specialized to deal with metadata relevant for technical communication. And usually in traditional processes, all these product data or product metadata is just built again inside an authoring system, but we could use, or we will have to use, the metadata for the technical communication provided from product information management system. So what has to be done is the management of the metadata has to be implemented in a system outside an authoring system, outside a component content management system. And the second conclusion is, as there is metadata involved from many different system and usage scenarios, we have to connect all this metadata to build an application-wide and also application-independent information model to make it ready to fulfill information delivery needs which will arise in the future and which are not known now. And with this application-independent representation and management of the metadata and the interconnection of the metadata to form a knowledge graph, the metadata is ready to be used in existing scenario, but also in future ones. And as I said on the last slide, which already existing standards could be used. We, within Empolis Content Express, are using the Intelligent Information Request Delivery Standard of the TECOM, and the goal of this standard was and is to offer a harmonized metadata model relevant for technical communication, but also able to represent all product models, features, function, properties, and variants, and to use it as an annotation model for the technical communication.
So, what we want to do is to get the metadata out of all the individual systems and create a big central metadata management system that actually holds all the metadata and can supply metadata to these application scenarios. And you call that?
A digital information twin. Thank you, Ulrike. Yeah, that's what we call it inside Empolis Content Express. And a big part of this digital information twin is the digital twin of the product. And as Ulrike explained, it just consists of a bill of material, the properties, the functions of a product, the components, the hierarchies, and probably also already existing messages, system messages, and error messages. And this part is connected to the traditional metadata from the technical communication, describing the actions of a user, describing the functions of a product, grouped by, for example, the product life cycle phases of the product. And it will be combined with a generic information model for technical documentation content. So we don't generate a document structure for every product again, and always more or less the same information structure. Instead of, we are providing a generic information model for what has to be documented in a generic and product independent way, which will form the third part of this digital information twin. And this information twin is representing all the metadata necessary for annotating the content that can be used in the different use cases and scenarios Ulrike provided, and even more, the already existing information units are part of this digital information twin. So I do not only have the metadata, but I do also have a source for all existing information units connected to the appropriate metadata. And having a digital information twin like this, it's quite easy to switch to a dynamic creation of information products and to leave the phase where we try to produce documentation and where we try to produce documents and books in advance to cover all the different use cases, because this information model contains also the relations between the products, function, actions, and more. And therefore it enables to derive actions for which component is due in which time frame, providing all the parameters of a usage scenario which are part of the metadata model. I can just look at the graph and try to find the relevant information units. And I can also connect these nodes of the digital information twin with concrete requirements of users. And as soon as I know who wants to have access to information for a specific use case, I can just mark these nodes in the knowledge graph, and then I'm able to dynamically build a new information product out of existing content, because With looking at the nodes in the graph which are necessary, I can traverse through the graph and I can find the relevant information objects to dynamically combine it to an information product. And this does not only offer a solution out of static content and the dynamic creation of information products, it do offer a second solution. This is what we are talking about when we talk about paradigm shift. Because when I'm trying to generate an information product out of existing modules, I'm also able to identify lack of information. Because using the generic information model, adapting it to a specific product, to a specific variant and to a specific use case, I'm also able to find where no information unit exists at the moment, but where I would need one. And using these lacks of information, I can generate a request for content for authoring system, and I can only order small parts. The people in the technical communication, they don't have to think about a document structure anymore. The document structure is already provided. It's already part of the information model. I can just identify missing parts. I can generate templates for the missing parts. So I'm also able to annotate all the required metadata. And I can assign this missing part to the technical communication as a request for content, so they can focus again on actually creating content. The metadata is already there. The location in the digital information twin is already there. And the only thing what's missing is what the people from the technical communication can do best, writing content.
So that means we have this central hub in the middle which contains all the metadata and which may support both the usage scenarios and actually trigger the CCMS to deliver content. So as Achim said, it would generate a request for content. And we brought you an example. The example is you have in engineering. Engineering says, okay, the component is ready. You can now start documenting it. Please write the documentation for this. And as Achim said, this query goes to the graph. It has all the product information. It's about this component, and this component has those features. And then it can search in the graph which content is already there and which content do we still need. And you can see here in the image, the yellow dots represent contents that already exist, and the yellow and white dots represent content that still needs to be written. So this request for content actually gives a structure to the technical writer, telling them what they need to add, which content they need to add. And this is the view in the backend.
Where you can see that actual knowledge graph technology is used. So it's not just a model or screenshots for the marketing, but also a living knowledge graph based model representing the digital information twin and also the existing content, where we derive the missing content, where we generate a request for content, and where we are able to offer this request for content for authoring systems.
And the best part is that all the required metadata is already assigned to the information units, both the topics that already exist and the topics that still need to be written. So all the management of metadata is outside the CCMS. Rather, the topics already come with their metadata. So the technical writers get this request for content and can now start creating the missing information units. For this, they can also use fragments if they want to reuse content that has already been written for other information units. And once they are ready, they save the units, and the digital information twin gets the information that for these nodes there is now content available. So when the next request for content is generated, the new content can already be integrated and sent to other technical writers. That also means that we have diversification of roles in technical communication, because we have this metadata modeling. Somebody needs to maintain a digital information twin, and somebody needs to define the templates that come with such a request for content. We have the role of the information architects. Information architects will be responsible for maintaining the metadata model, at least the part that is responsible for a technical communication. There will still be technical writers who can focus on researching what the target audience needs. They can focus on creating content and organizing reviews and translations. And if you require so in your company, there may be also a role for a project manager who handles the request for contents. So that means instead of the 3-stage process that we saw in the beginning, we have a 5-stage process that starts with actually modeling the metadata and maintaining the digital information twin. This digital information twin needs to have interfaces to other systems, both systems where it gets information from, like product information, and system where it delivers information to, for instance, websites or content delivery portals. And after the modeling phase, we have our 3 usual stages: creating, translating, and delivering. But the delivery is different. We are now able to deliver also individual information units, because each chunk of content is equipped with its metadata and can thus be placed in other systems where the document may already be published. Because at the end of the delivery phase, there's either information product or information units, which are then in the processing stage processed by other systems. And this may be service applications or HMIs or content delivery portals. So as you see, the picture looks a bit different now at the end of our journey, and the metadata are right in the middle of it.
Yeah. And as a short summary, as we try to explain why metadata is and will be a game changer, and the time is over where you thought probably you can hide yourself and you're not affected by this metadata models. They will come. You will have to deal with it, because otherwise you won't be able to satisfy all the use cases we showed at the beginning. But besides of the importance of the metadata model just to fulfill all the requirements, we also wanted to show you that once you start dealing with these metadata models, once you will build your own generic information model and combine this information model and the metadata to a digital information twin, you will be able to establish this paradigm change with letting the generic information model and the digital information twin do all the annoying work of generating information document structures, and also let the digital information twin do the work with annotating all the required metadata to the content. And if you're interested in how this actually works within Empolis Content Express and how do actual project examples of Empolis Content Express are looking, feel free to contact us on the fair booth or in the following days or weeks. Thank you very much.
Thank you.